Hi there, it's Matteo from Omnistrate. Today we're gonna have a Prometheus demo. So let's jump right into it. I'm importing a Docker Compose because it's a custom spec. So Prometheus demo, this is my Prometheus demo in BYOA mode. We're gonna see that in a bit. We have a logo URL for Prometheus just to make it fancier. Now, this is our spec. Let's see how it goes. We have our version, and then we have a custom parameter, which is X Omnistrate BYOA. This allows us to have an AWS account set and a role that we previously created through our Terraform scripts. Then Omnistrate integrations is another custom parameter that allows you to enable some of our capabilities. In this case, I enabled only logging and metrics. And then you have a service definition with the image that we built. It's a custom one. Then we set a volume. We have storage for both AWS and Google Cloud. Then we have our ports, our 1990. We have a scrape interval. We have all the environment variables for Prometheus to work. We have some API parameters like the CSV of targets, the storage throughput, and the I/O per second. We also have some default values, build service. And here it is. So we need to connect our customer's account. In order to connect to our customer account, we need to create a cloud provider account instance. I previously run the scripts that are described here to obtain the Bootstrap role ARN and the AWS account ID, which now we'll just cheat into it and just keep it this way. So this is it. Now we're going to create the cloud provider account instance. We are going to wait a couple of seconds and then it's going to be ready. And we're back. So after the account has been connected, now we can create the Prometheus instance. We choose our cloud provider, Amazon Web Services. We choose our region, US 1. We choose the account config that we previously created. And then we add our target to scrape. In this case, I'm using localhost 1990, so it will scrape the Prometheus metrics. Of course, you can choose your own target. And okay, now it's deploying. Let's come back later. Our instance is running. We can see our targets to scrape, our config. In the connectivity tab, we can see the Omnistrate observability endpoint, the Prometheus endpoint, of course, the ports. We can see the node running, health status. We can see some metrics going on, and we can see the logs. After that, let's go to see what happens if a customer that is not onboarded in our account configuration needs to be onboarded. So we're going to deploy 2 instances using 2 different accounts, of course. In order to create a connection with our second customer account, we need to create another instance. We can click here to download our Terraform kit. We need to run the Terraform scripts. Now I renamed a little bit the thing. Initializing the backend. And let's see you in a minute when I'm gonna run the apply. Okay, now that I have my Bootstrap role, I can copy the ARN and the account ID. Okay, let's see you in a second when the connection is created. Now that the instance has been created, we can list our resources and create another one. We choose a region. Let's choose a different one, which is our newly created instance, and which is our target to scrape. Now the instance is deploying. So we have now connected the second instance. It's deployed. It's in another region. Now we can also deploy them on the same region. And here they are. As always, we can see the logs, the metrics, the node health, and we can now see what happens if I want to update one of those. Now let's go back to our list of service definitions. Let's hit build services. We already have pre-selected our Prometheus. And let's hit build here. Now, in this interface, we can do a couple of things. We can edit our service component. We can configure our parameters. Let me show you how it goes. So this is the kind of parameter we can support. We added an instance type. This is one of the changes that we made. Yeah, we can add an API parameter. We can define if it's modifiable, if it's required, a default value. After that, we can also change the image, which we already did. So we change it to 2.2 instead of 2.1. And we can also change the infra. We can view it even. Yeah, we can hit next. Can attach the infra. We can configure the network, storage volumes. Let's just see. Yeah, we can create a storage configuration. Then we can hit our integrations. In this case, I already activated logs and metrics, as you have seen in the previous steps. And we can go to release. Now, what happens when you go to release is that we summarize the changes of the image, for example, of the infra, and then we propose you to release. Plan version name is something that you can choose that should describe what you're doing with this change. In this case, upgrade to image version 2.2. Then you can either release or release as preferred. Now, release will just add it to your list of releases possible, while release as preferred will make it so every new instance will be deployed with a new version. Now, in this case, let's just hit release. Okay, here it is. Now, instead of accessing the plan, we are going to manage fleet. We're going to schedule the upgrades. It is time to upgrade our image. Now, as you can see, I already started a few upgrades. Some of those have been deprecated because the version is not anymore the viable one that we want. We still have one of our instances in an older version, and there is one in the stable one. Let's say the 7.0 plan is a stable one, but we also have a new one. Keep it in mind. Now, I want to upgrade the old version, so this instance right here, to the 7.0 to align it with the other one. Now let's hit next. This is the upgrade that is going to be done. And I'm scheduling the upgrade right now. Now, this is a screen where you can manage the upgrades. As you can see the source version, the target version, and see if it's completed, in progress, failed, or pending. In this case, it's pending. After a while, you will get the workflow ID, where you can just navigate to see the status of the workflow itself. In this case, we are also deploying the observability on top of the Prometheus instance. And let's see in a minute how it goes. Here it is. The upgrade has been completed. The instance is running. And we went from the source version 1 to the target version 7. Now, let's try a rollback and to bring this to version 1. We schedule an upgrade and we can see instance count, create an upgrade plan. Now we can choose either of the instances actually, and let's revert it back. Yeah, of course, we got a notice. That's very nice to have. We are noting that you are downgrading, so please make sure that your Docker image is backward compatible before moving ahead. It makes total sense. Now, let's schedule the downgrade. It's also impacting, of course, the infrastructure. We are changing the underlying infrastructure in the cloud provider side on top of the image and the component itself. Cool. Our rollback has been completed from source version 7 to target version 1. Now, let's schedule an upgrade to version 8. Schedule upgrades. Now, as we can see, we completed 2 upgrades. We can go from here to create an upgrade plan. Let's select the 8 version. Next. We see, of course, it changes again the infrastructure. We do it seamlessly. Okay. And then let's schedule another upgrade for the version 7. Create an upgrade plan from version 7 to version 8. In this case, we just change the image, and the component, but we don't change the infrastructure since the infrastructure change has been done in the previous version. Okay, now let's wait and let's show you the final result. Okay, great. Our final update has been done. So from version 7 to version 8 and from version 1 to version 8. So great so far. Now let's see if the instances are actually running. Access service, dashboard. Instances are up and running at the latest version. So to recap, we can deploy on 2 different accounts, seamlessly managing a multi-cloud instance. Then we also manage the rollback, we manage an upgrade, we manage 2 different versions of the same component. So imagine a customer wants a separated version because they have different features, or they just want to have your latest version and not the stable one. You can do it. Then we showed how to implement different parameters and to personalize your SaaS. So you have basically everything to keep your SaaS in shape from a single pane of glass. Okay, but let's see what happens when an error occurs. Now, I logged into the cluster and in the infrastructure side to trigger an error. I filled this with junk. So now our Prometheus should be failing. The instance is running, which is right, I would expect it. But then if I look at the node, I see an unhealthy status. And that's worrying. So let's see what happens when we find an unhealthy status and we trigger automatically our alerting system to show you the error. As you can see, my pod is in crash loop back off. So I triggered correctly the error. And let's see now which kind of alert I get. Oof, here it is. I found the error message on my monitoring service prod alerts, which is a channel on Mattermost, our internal chat system, which we self-host, by the way. And I can see some error, port scan, TCP, Prometheus 0, this is my instance. I can see some details, the assignment, which service triggered it. And in this case, I'm integrated with PagerDuty, so I can click through and go to PagerDuty. But we can integrate with your favorite alerting system. Basically, that's how we catch errors. So you're always up to date and you can trigger some automatic resolution or whatever you want. We integrate perfectly with existing workflows. That's how we handle errors at Omnistrate.